Hello and welcome back to another Orange Coast College Mathematics video. In this video, we're going to be talking about solving different exponential equations. One good trick to use when we're trying to solve exponential equations is to actually get equal bases. So what do I mean by that? Well, let's go ahead and look at number 1 and we can illustrate what I'm talking about. So we have 2 to the x power is equal to 64. Now, what I want is I really want to turn this 64 into 2 to a power. If I can write 64 as 2 to a power, then all I have to do is just equate the exponents together. And so, let's go ahead and think to ourselves, can I write 64 as 2 to a power? Well, I can write 2, if I go to the second power, it'll be 4. If I go to the third power, it's 8, and then the fourth power is 16. 32 is the fifth power, and then 64 is the sixth power. So I really can write 64 as a power of 2. And so we can write 2 to the x is equal to 2 to the sixth power. So now that the bases are the same, now that they both have a 2 right here, I can just equate the exponents. So we get to say that x is equal to 6. And we're done. Now, number 2 kind of looks like a mess, and it is, but let's go ahead and just try to get things looking as simple as we can. Now, the right side is dealing with a fraction. I don't want to have a fraction in here, so let's go ahead and deal with that. Now, how can I write 8 as a number to a power? Well, the only one that I can really think of is 2 to the third power. And so we can write 4 to the 7 minus x power is equal to 1 over 2 cubed. But I still don't want to have this fraction, so I can move the 2 cubed into the numerator by putting a negative sign on the 3. So this then becomes 4 to the 7 minus x power is equal to 2 to the negative 3 power. Now from here, I'd like to get both of these bases to be the same. Now I know that I can write 4 as a power of 2. I can write it as 2 squared, so let's go ahead and do that. We can write the left side as 2 squared to the 7 minus x power is equal to 2 to the negative 3 power. Now the properties of exponents just allow me to multiply these to become my new power. And so we're going to be left with 2 to the 2 times 7 minus x power is equal to 2 to the negative 3 power. But the cool thing is that now my bases are both 2. And so I can equate my exponents together. So this is going to give us that 2 times 7 minus x has to be equal to negative 3. Now we can start trying to solve for x, and so let's go ahead and distribute this 2. So this will become 14 minus 2x is equal to negative 3. And then we'll have negative 2x is equal to negative 17. And then finally we get that x is equal to positive 17 over 2, or 8.5. Let's go ahead and check out number 3. Now, number 3 is a little tricky. I have 9 as a base on the left side, and on the right, I only have a 1. I want these to have the same base somehow. And so we think to ourselves, is there any way that I can get 1 from a power of 9? I can, if the power is equal to 0. So I can actually write this as 9 to the x minus 4 power is equal to 9 to the 0 power. Now, the bases are the same, and we can equate our exponents. So we can say that x minus 4 has to be equal to 0. And so we settle down on x being equal to 4. Let's go ahead and move on to our next problem. So for these problems, we want to find the exact answer and an approximation to 4 decimal places. So starting off with number 4, I see that I have e as a base on the left side, and then I have a 3 on the right. It's going to be very difficult for me to try and write 3 as e to a power, so I need to find a different way of dealing with this. Now, if we remember, logarithms and exponential functions are actually inverses of each other. And as long as I do the same thing to both sides, it's a legal move. And so, I can take the natural log of both sides. We'll get natural log of e to the 2x plus 1 power is equal to the natural log of 3. Now, since natural log and e are inverses of each other, they're actually going to cancel each other out, and we're just going to be left with 2x plus 1 on the left side. So, we're going to have 2x plus 1 is equal to the natural log of 3. Solving for x, we're going to have 2x is equal to natural log of 3, and then minus 1. And then finally, we'll have x is equal to the natural log of 3 minus 1, and then everything divided by 2. This is our exact answer, but if I were to plug this into a calculator and round to 4 decimal places, we're going to get that x is going to be approximately 0.0493. And so we have our answer. Let's go ahead and check out number 5. Now, number 5 starts off in a kind of similar way. We have a base of 2 and then we have a base of 7. It's going to be really difficult for us to be able to turn these into bases that are the same. And so we need another way of dealing with this. Now, we're trying to solve for x, and we notice that our x's are in the exponents. One of the ways that we can get rid of exponents is through the properties of logarithms. And so we can take the natural log of both sides. And so if we take the natural log of both sides, we will have the natural log of 2 to the x plus 1 power is equal to the natural log of 7 to the 2x minus 1 power. Now, the properties of logarithms say that I can take my exponent and just drag it down and multiply it in front. So this then becomes x plus 1 times the natural log of 2 is equal to 2x minus 1 times the natural log of 7. Now, this is going to look a little ugly, but we need to make sure we get all the x's on one side, and I can't do that without distributing first. So let's go ahead and distribute. We'll get x times natural log of 2 plus natural log of 2 is equal to 2x times natural log 7 minus natural log of 7. Now I'm going to go ahead and get all the terms with x on the left side, and then everything else is going to go on the right side. So we're going to have x times natural log of 2 minus 2 times x natural log of 7 is equal to negative natural log 7 minus natural log of 2. From here, I can take all of these terms that have an x in it and I can factor it out. So this then becomes x times natural log of 2 minus 2 times natural log of 7 is equal to negative natural log of 7 minus natural log of 2. And now I can go ahead and isolate x by dividing by this whole quantity in the parentheses. So we finally get that x is going to be equal to negative natural log of 7 minus natural log of 2 divided by natural log of 2 minus 2 times natural log of 7. This is going to be our final answer. And if you were to plug this into a calculator, we would get that x is approximately equal to 0.8250. Now, as a little caveat, your exact answer might look a little bit different than mine. If you instead opted to use the common log, so just log base 10, instead of the natural log, well then all of these natural logs will be common logs. You could have also used log base 2 or log base 5. As long as you did the same thing to both sides, it was a legal move, and so you got to choose what base you wanted for your logarithm. However, no matter what you chose for your base, you're still going to get the same approximation if you were to plug it into a calculator. Okay, so let's go ahead and move on down to our last problem. Now, this one is really tricky because in secret, this is actually just a quadratic equation. The way that we can get this to looking like an actual quadratic equation is to make sure that this base right here of 4 is the same as this 2. And so what I can do is I can rewrite 4 as 2 squared. So we get 2 squared to the x power plus 2 to the x minus 12 is equal to 0. Now the properties of exponents allow me to just switch the 2 and the x right here. And so I can write this as 2 to the x quantities squared plus 2 to the x minus 12 is equal to 0. Now if we look a little closer, we see that we have something squared plus that same something, but now this is to the first power, and then minus a constant. This really is just a quadratic. Now, even if you can see it as a quadratic in its current form, it still looks a little ugly and is a little hard to work with. So what we can do is we can just give 2 to the x a new name. So I'm going to go ahead and say, let a be equal to 2 to the x. I'm giving it a new name, or a nickname. So now when I write my equation, it looks like a squared plus a minus 12 is equal to 0. Now this clearly looks a lot more like a quadratic than our previous version. And so we can just go ahead and factor. This then becomes a plus 4 times a minus 3 is equal to 0. And now our zero product property will tell us that a has to be equal to negative 4 and a has to be equal to 3. Now that I know what a is equal to, I can go ahead and go back into the 2 to the x form, because I'm really trying to solve for x, not a. And so if we replace a with 2 to the x, we get 2 to the x is equal to negative 4, and we get 2 to the x is equal to positive 3. Now we can go ahead and look at this left one, 2 to the x is equal to negative 4. Does it make sense that a positive number to a power is going to be equal to a negative number? And the answer is no. I can't actually have that ever happen. And so, this is actually not possible. So, there is no such x value to make that equation true. Now, we can go ahead and check out this. This is just an exponential equation, and we can turn it into a logarithmic form. And so, we can write this as log base 2 of 3 is equal to x. And that is our final answer. If we were to plug this into a calculator, we would get that x is approximately 1.5850. And with that, we finished our problem. Well, that's going to do it for this video, and I hope to see you in the next one.